to the super long slides. It's really useful. First, the method part, you specify what training method you want to use. Second, number and repeats tell the model how should they resample your data. This one tell the function whether you want to print a log. Usually we don't do that because it's super long. Return data means whether you want to save all your training data set. Class prompts is telling the model whether you want to print the result of 1 or 0 or the percentage. Like you are doing a classification for disease. You want to know it's sick or not sick. It's 0, 1. If you use this parameter, it will tell you how much percentage these people will get sick. And the summary function is the one you specify what is the criteria to select model. Like the default one is accuracy rate. No, it's fine. I'm glad you joined. Welcome. And the selection function tell the parameter whether you want to use the best performance or the simplest combination of variables. So it's your criteria. And return resample will decide whether you want to save the model or not, and how to save it.
What's a slot?
Slot.
Saving the data into a slot, return data.
Fourth one down.
This one?
Yeah.
It means a file. Or
Okay, it's not like a specific object.
No. No, nothing calls slot in R. Sorry. It's confusing. Okay. Oh, it's cut off. It's weird. It looks fine on my printout. Okay, I will fix it. So, how do we do performance? For regression, we use RMSE and R2, R squared, to do performance. For classification problem, we use accuracy and kappa. And if you only have 2 output, you will use 2 class summary, and your criterion will be sensitivity, specificity, and the ROC curve. So who can tell me, should we choose ROC curve bigger area or small area? Which one is better? Like ROC curve is look like this, and the area underneath the ROC curve will tell us how good the model is. Cool.
This kappa,
I forgot too, sorry. And you will notice in metrics you need to specify ROC, and corresponding part spaces summary function will equal to 2 class summary. They are corresponding to each other. Make sure you use both of them.
Excuse me, say it again, what is this 2 class summary?
It means you only have 0 or 1 output.
Okay, binary.
Yes, binary. So this is example when it will print 0 and 1, when it will print the probability. When you specify the type equal to prob, it will give you percentage. But the default one is 0 and 1. So you have a bunch of models. How should you select? There are several ways. The first one, we use confusion matrix, and it's quite standard. After you do a model, you will do like, this is the observed value, this is the predicted value. I want to know how they compare. Yes, cross tab, exactly. Or cross tabulation, same thing. And this is the most easy one because we're using model it's called density plot. Then we can do multiple model comparison. called between model comparison. The most important part is here, decay, size, and the back. Right now, I want to show you a quick example. So I fixed this part and this part, and only having 1 to 8 in the size. But you can make them flexible, all of them.
How would you do it?
0.1, 0.2, 0.3, something like that. And who can tell what training method we're using here? AB, net, what method it is?
Neural net? Analysis
Usually NN is neural network. And these three parameters, they have a dot in the front. They are the specific parameter we want to pass to neural network. And in trace equal to f and the line out equal to f, there are also specific parameters for neural network. So whenever you use certain method, remember the combination for their feeding parameters. So just notice trace, line out, decay, size, and back. If you specify line out equal to true, that will become regression. So just be aware about those parameters. Okay, cool. So we can use a lot of methods. How should we compare them? I did a comparison between tree model and the neural network. It showed neural network is better than decision tree, but it's hard to understand because neural network is like a black box. You don't really know what's going on there. And sometimes the hidden layer number will affect the result a lot. You need to find the best hidden layer. So
it's a hidden layer, right?
Hidden layer. It's like you want to aggregate knowledge layer by layer. Like you have 3,000 nodes. Yeah, you can control, but you don't know which one is the best. That's why people feel like it's a black box. You can't have fully control of it. Also, we can do a t-test. If the p-value for t-test is really small, like smaller than 0.5, it shows neural network is significantly better than decision tree. This one, I want to introduce you the variable important function. This is the one we want to use to select most important parameter. And I mentioned there are two approaches to decide which variable is important. First, you use model. Second, you don't use model at all, just looking at the parameter.
What does it mean, not having model at all, just looking at parameter?
For classification, you can do ROC curve on each parameter.
Okay.
That will purely tell you what's going on
Right.
in the.
Without
So
any
it's
model.
not model dependent.
Okay, yes.
And for regression, you have the same thing. You can the regression coefficient doesn't really depend on any variable or modeling. It's pure math, right? Also, if you pay attention to VAR important and VAR important use model equal to true so forth, the default is true, and this one will calculate ROC curve for you. This one doesn't. That's so different. And this is model based. This is non-model based. Non-model based, we use ROC curve for regression or classification. So there, you need to be super conscious about what data you have, what kind of result you want to produce, and the criteria to evaluate them. They are all related. So, when we do feature selection, there are three types of feature selection. First, your model will having their abandoned function to select variable. Second is you need to use a wrapper function to make sure modeling and the selection happen at the same time. Or you can do a filter. You can pick what variable you want to use first and fit them into a model. So there are delicate differences, but be aware of what's going on there. Also, for high dimension data, sometimes you want to do dimension reduction first because it's not efficient to do all the modeling fitting. Okay, another scary one. What do we want to learn from this one? I will give you 3 minutes to read this one.
Just a big picture question. We've seen that this package has many methods available.
Mm-hmm.
Are these methods done by this package's own implementation of them, or are they all just wrapper functions for other packages?
It's wrapper function for other package. So it saves you a lot of trouble to running around. I really like it.
How long have you been using it?
What?
How long have you been using it?
Me?
Right.
I can't tell. If I tell you, you will know how old I am.
No, but it's not at all. It was only invented 5 years ago, so right?
Really?
2006 or so?
Really? Oh. No, you can like calculate when they learn this. It must be around college, it's a strong indicator. I won't learn this in high school, right? Have you guys finished reading this?
Mm-hmm.
Cool. So the main takeaway from this slide is every time when you do a training, you keep the most important parameter. It's like you get rid of the parameter one by one. And how can you make sure your model is not overfitting the parameter set? Right? So you want to make sure your resampling part always outside of the scope of get rid of the variable. If you make sure you resample out of the selection part, it's less likely you will overfit because you keep changing the data set. You keep get rid of them based on different data set. Sometimes people unconsciously put resampling inside of the getting rid of variables process. That's the main reason their model will fail. So just make sure resampling always out of the subsetting their data set. Okay, cool. So we're moving to random forest. How can we tell this is a random forest? RFE control RFE size equal to 1 to 8 is telling the function you want to reduce the size from 1, 2, 3, 4. It's like trying out what kind of random forest will work for me. And number equal to 10 repeats equal to 3 tell you this is a 30 times cross validation process. And how it works. For example, if you have 8 parameter, it will keep giving a score to the parameter. Like I will give a score to 8 parameter, which is the best one, which one is the weakest one. We will get rid of them. And we keep giving score to 7 parameters, 6 parameters. It's like filtering them out. And I mentioned there are a few functions for linear regression too. It's LM functions, RF functions, naive Bayes, that will be NB funcs. And backtive trays. There will be tray back funcs. So you can try them out later. Let's just show you they're all available.
So all of these are only used for the feature selection so far, not for predicting. We are still at the feature selection level.
No, this is the training part. After you set up the training part, you can do prediction. It's just set up the training.
Okay.
So if you go back to the flow, like pre-process, splitting, map them up, you will know which part you are.
Okay.
So Caret is really strong at 2 parts. Let's go back. Okay, this is really advanced. So if you don't get this, it's fine. After you get the funcs, Caret has it, you can actually customize it, make it yours. Like you want to have a summary entry, just define it, how the summary will look like. It's similar to you want to print out a summary of your regression, but all the options in the summary doesn't fit your need. You just add extra stuff to your summary statistic. So it's highly customized to your need. And we're moving to parallel computing. It's really neat. You can use library to parallel, and that is how many core you want to use. And if you run this page, you will find out this takes about 50 seconds. This takes about 2 seconds. It's the without online machine. And everything is the same. As you call it without aware you can parallel it. So just specify the core you want to use, all the other part is the same. It's not like Snow or other parallel package you need to care about the tedious details. This one just has all of it. Okay, it's the exercise 1. Unfortunately, I print this out. So we will do another exercises. This one I was trying to ask you to use KNN to do a training function. First load the package and specify what kind of training set you want to have, how to do resampling. You feed it here. How can you feed the parameters? It's here. So and plot the result. That's basic how can you use it in your work. You already learned how to split the training set and the predict column.
So the sequencing, is it from 3 through 20? Is that what it means?
Yes, it's a step through. So it's 3, 5, 7 like this.
Okay.
Cool. So let me introduce the example. How many of you have tried Kaggle? Kaggle.com? What's your rank?
Me? Not very good.
Have you tried the handwriting example?
No, I know you're talking about that, yeah.
To detect the numbers.
I haven't tried it, but...
So if you have taken classes on Coursera, the machine learning class will teach you how to do it in Octave, right? Using neural network. And also, there are a lot of R example how you can do this handwriting. So it's like it's designed for post office. They want to read what kind of zip code you write there. So they have huge training set. They hire someone to do it. Like this is 7, this is 1, and they will do a corresponding prediction model on this, and they can process your letters faster. So Kaggle have a free competition. Is this still available now? Still available?
Last I checked, it was.
It sounds like a long-term competition, right?
Yeah, it's like one of the ones they have to like introduce you to the format of the competition.
So
There's another one about, I think they have one about with the iOS data set as well.
Okay. So I'm not sure how many of you have been to the Amazon employee challenge sharing we did a few months ago. The lead data science at my firm is ranked top 0.1% at Kaggle.com now. So this is solution he made for me for the handwriting. So for Kaggle example, their total 43,000 sample. It's the training data set size, and the testing data have 28,000 sample, and the training set have 785 parameters, and the testing set have 784. It's reasonable, right? We're missing the y parameter there, and each sample of the picture have 28 times 28 pixel. So we first flag them into a vector, and there is a package called EB image. It can help you to convert your gray picture into just black white. So it will reduce the data dimension. And Kaggle gives you a basic score. Right now, if you use random forest, you should be able to get 96% correct rate. So the goal is to improve upon that. That's the baseline, 96%. So how can we do that? So steps, first you do some pre-processing, normalize it, and transform it into 0-1 range, and convert this from gray picture into black and white picture. And this is the amazing part. We constructed our own parameter. How can we do that? There is the EB image package have a function called compute features. Basically, it helps you to identify the shape of the object. If the shape is more localized 1 or 2, it will draw the boundary. It also will tell you the center of the picture. Like 8, you will consider the center is in between 2, 0, right? Mm-hmm. And 2, they have different centers. It helps. Also, it will calculate, like for 7, this side is longer than this side. So use this package, EB image and the compute feature, you will be able to extract 10 features. That's your basic feature. The second group of the feature we did is, if you consider it's a square box, you have 6 lines. Like you cut in the middle, and do a 2 diagonal line. Each row, each cut, you will touch on the numbers, right? If you, for example, it's 7, you cut across, you hit the number once. You cut in the middle, you might hit it once or twice. And you cut on diagonal, you can tell which cut, how many times you will hit the number. It's also very important criteria. It will generate 6 parameters for you. Also, we want to go out from the number. If we detect the center of the picture is like in 20 times 20 position, we want to go 8 direction out to see where we touch the numbers. Right? Sounds amazing, right? So you can generate 8 parameters based on the center and reach out how soon and how many times you reach to the handwriting. Did I explain this clear enough? Did you get the idea? Cool. Also, you can cut the whole picture into 6 small squares. and calculate how many pixels exist in each square. So by doing those 4 steps, you should be able to generate your own 72 parameters. And using the 72 parameters, you can already get 96% of correct rate. You are not using any parameters. They're giving you the 700 something parameters. So this is really fast. But the goal is we want to improve upon the 69%. How can we do that? How can we select more from what existing there? So
It's only for numbers, zip codes.
it can be applied to anywhere as long as it's handwriting, right? It can be applied to letters and address. But the letter one is most well trained because they hire a lot of people to read the letters and tell. They have the data set, what exactly this handwriting should corresponding to.
I was thinking the best way to know if something's a 1 or an L is to look up the neighbors.
Neighbors means.
The letter.
Well, that's more like the 8 is the surrounding.
Oh,
Surrounding.
okay. Yeah, we have the neighbor parameter, right? Okay, so I mentioned for decision tree, it can get rid of non-important parameter. So we use tree to select the most important 50 parameters and get rid of all of them, all the rest of them. And combining the 72, we get 97.5 correct rate. And it's super fast.
Does Caret package take care also of other classifiers like random forest and SVM, Gaussian mixtures?
I haven't tried SVM, but in the second last slide, it's random forest. It's starting from RF.
Yeah, but there's a whole bunch of classifiers, order logic, multinomial logic.
I haven't seen Lasso or Elastic Network. I haven't seen SVM, but I guess they're moving there because the whole point is to wrap everything up so you
Then
can
Python
use it.
is better now. I can.
I'm going to do a benchmark along the stuff. You can join me, please.
Absolutely. Thank you.
Okay. So in the end, we did our SVM, and the correct rate is we use support vector machine because it helps us to further tune the method, and it's more robust when we submit to the server. That's it. And any question? There is a saying that data science is the new spot. How do you feel about that?
It's the new one.
New spot. It's the new fashion in fashion.
It's a big deal, especially when proprietary data, which is usually in databases in proprietary data like financial data, proprietary data is mixed together with data which is publicly accessible via social networks. So, this is going to be, but this methodology is being improved. Well, you already have, all the
So
stuff.
for everything we have on for this meetup, I have archived it on NYC Open Data.com. You can go back for the source code, the videos, and sometime if you want homework, I can post homework there. And you can sign up for the newsletter.
So can you tell us what are some of the common uses for the Caret? What are people using Caret for? And usually.
Guys, don't go. I need to check you in. I track no show. Like last week, we have 220 people sign up for the hack session, and only 11 people showed up.
Oh my gosh.
And it's the fourth time. It's not the first time.
Statistically significant.
Yes, and I remember the first time when it happened, it was my daughter's birthday, 1 year old. And I have like 140 people on the waiting list. Only 6 people showed up.
Oh.
So please check in with me so I know you didn't do this to me and you didn't break my heart.
More than 11.
What? I think so. It's the first time we have 100% check-in rate. Thank you so much. Can I take a picture? That's awesome. Thank you so much. Hi, if you like me, please smile. Oh, full house. I'm so proud of myself. And cool. Please come to me so I can write your name and thank you for coming on the NYCOpenData.com. Everyone know you keep your word. Where is my network? How about we do this here? Justin, right?
Yep.
And KD. Zach. Also, it's good time to know the pretty girl sit beside you. Is this how to spell that? ZAC, sorry. And
Oh, you get Calvin.
Cabin.
What do we do in soccer?
CAL.
Oh,
Close.
AL. Right?
BI. Yeah, no D.
Okay. Oh, okay. Let's do F. Sorry, I can't spell name. I did it right yesterday, right? Forgive me. Forgive me.
You need a statistical package for spelling.
Yours?
Luis, L-U-I-S.
L
L-U-I-S.
L-U-Y
I-S.
I-S.
Yep.
Yasna. J-A-S-N-A.
J-A-S-N-A. Yan. Robert.
Yeah, with a final low.
And
Brian.
Brian.
Sorry.
How to spell that?
C-O-R.
C-O-R-Y. How to spell that? A-R-N-A-D. A-B. Sir.
Roma, R-O-M-A-N.
M-A-N.
M-A-S. M-A-N, sorry. Your name? Chris? Tina. You're so friendly.
Wrong. Same.
Roman, what's your last name?
I give you mine. K-U-B.
K. Okay. How to spell that?
A-L-E-J.
A-L-E.
Alejandro.
J.
J. A.
A.
No, A. N.
Lady Gaga has a song similar to that.
L.
D. R-O.
R-O.
Where are you from?
Alejandro.
Thank you. Richard?
Christine.
Partido de fútbol de México.
Yes.
¿Cómo jugó México, verdad? No sé. Contra Australia.
Nueva Zelanda.
Richard, thank you for coming.
Pero no sé cómo le... Creo que es colombiano.
Sì, sì. È un gusto.
I will post an update on the meetup board for the location of the code and the
It's on the NYCOpenData.com. I will send the
just
reminder.
send the link.
I will.
Alright,
I always
alright.
do that. Did you have fun?
Yes, absolutely. Actually, it's interesting. I'm
How
using
to
classification.
spell that?
NYC.
Can you wait for me? I would want to talk to you more.
Okay.
NIC.
I watch a lot of Bundesliga.
NIC.
NIC.
L
think it's actually good to
N
No L.
O N.
No L. No M. L N. No L. N. Yeah.
Oh my god, I feel bad. Oh my god.
Thank you very much.
Thank you for coming. At least, right? Well, sir? Yuri. How do you spell that? U-R-I? Thank you. You're a regular. I know that.
The book by Max Cool, right? He wrote the Caret, right? The book called Predictive Analytics, right? Is it good to learn more about Caret?
You don't need to buy the book because he has really good website. Just follow on his website. Will be good.
Okay, Mexico, right?
Yes, Mexico. His website is really good.
What are some other resources to learn more about Caret?
I just use his website. It's good enough.
So what are you, other than writing, what else are you using the Caret for?
Me?
Right.
I use it.
What other are you, so you are, give me some examples. What are some common applications for our common usage?
You mean business?
Yes.
It's confidential.
But general idea, don't I mean specific.
For example, you want to tell whether your employee should have this access for certain resources. Like he just came into my office and he's requesting laptop, database access, everything. And you want to decide whether you should use it right away or not. You can train a modeling to decide what to do with it. Amazon have this system. They have the solution on campus.
We are using Caret?
No, just because Caret is like on the top of all the training methods, right? You can decide what you want to do with it.
The slides from today's presentation, did you share them?
Yeah, I share everything on that.